Welcome back to the promo tutorial series. Last time, we walked through the basics of scripting, from declaring variables to writing your own functions. However, so far, we've only learned what types of building blocks are available and not quite how to put them together. If you're writing instructions for providing driving instructions, for example, to a fellow traveler, you can't just simply use action words like drive straight or turn left or turn right. You also need to provide conditional words like if and then. If you reach street X, then turn left. If you reach street Y, then turn right. In programming, we use those exact words to tell our code how to reach its intended execution code. Let's begin. So we are back in our maker, and from the last time, we've created our Lua tutorial script file. And just as a refresher of script files, these will run one time during the lifetime of our world and not be run anymore. To create this file, we can right-click on My Desk and hover over Create Scripts, and then click on the Create Script submenu. We'll also double check to make sure that in our console that we are only seeing logs from the client side, not from the server side. Okay, let's double click on Lua tutorial to open it up. And the first concept that we'll go over is the if-then pattern. So let's use our Booleans data type that we learned in the last example. And we know that Booleans hold either true and false values. So let's look at the if-then pattern using this Boolean example. So we've declared our variable have apples, and we've assigned that value as true. So our if-then pattern looks like the following. We have the if keyword that will begin the start of our if-then pattern, and then we have an end keyword to mark the end of our if-then pattern. We have the comparison logic that will hold the comparison that we are checking for. Then we have a then keyword that will signal the start of our code. So here, if our have apples variable is true, then we will log have apples. So when a Boolean variable is dropped in like this, it is checking for if this is true. So if have apples contains the value true, then we will execute the code in between our if and end keywords. In this case, we are just outputting the log I have apples. So because have apples is true, we should be able to log out I have apples. Let's press play and check if this is true. And we can see we are logging out true for the value of our Boolean. And we are logging out I have apples because have apples is true. Now, we also have an else statement where we can define what happens if it's not true. So we will just pop the else keyword in, and then if this is not true, then we will execute whatever is between else and our end keywords. So if have apples is true, then we will log I have apples. If it's not true, then we will log I don't have apples. Because have apples is true, we know that we will log I have apples. So let's try setting this to false so that we can log out the else condition. So we have our Boolean variable, have apples is false, and because it's false, our first condition is not executing, but our second condition is I don't have apples, which we can see here. So from the last lesson, we learned that our have apples Boolean type doesn't necessarily only have to hold the literal Boolean value of true or false. It can also hold the result of a conditional statement. For example, consider that we have a number type variable with the value of 2. So we have our apple count variable being assigned a value of 2. Then we can do something like this, where we reassign our have apples Boolean up here to our new value with a conditional statement of apple count is greater than 0. So we'll log this one more time, have apples, out to the console to double check. Then we will bring our conditional statement down below because we know that execution order does matter. So we want to make sure that our have apples Boolean is being reassigned to the right value before we do the if else check. So in this case, do we have more than 0 apples? Because apple count is 2, this should resolve as true. So our first statement, our if statement, should resolve and output I have apples to the console. Let's press play. And here we can see our initial value is true. then when we reassign to the conditional statement, we can see that apple count is greater than 0, which is true. So I have apples is being logged to the console. We can also, instead of having this boolean here, we can directly input this into the if-else statement. So instead of using our boolean count here, we'll actually get rid of this boolean, so we don't use this anymore. And we will log out apple count to our log instead. So we're doing the exact same thing. We are checking if apple count is greater than 0, but instead of storing it in a boolean variable, we are directly inputting it into the space between if and then as our conditional statement to be resolved. So let's press play again. And we see the exact same thing as before. Apple count is 2, so apple count is greater than 0, so I have apples is being output to the console. We can use the less than symbol. So let's say that we want to have at least 2 apples. We want to gather up to 2 apples. So if we have less than 2 apples, then we will say gather more apples. And in the else statement, we will say we have enough now. So let's try saying that we have 1 apples. So we still have to gather more. So we have 1 apple, so it's saying gather more apples. And then as soon as we hit 2, it will say we have enough now, because we now have 2 apples. We can also combine a conditional operator and an equal sign to say less than or equal to. So let's say, for example, if I have less than or equal to 0, then I'll say I have no apples. But in any other case, if it's greater than 0, then we will say I have apples. So logging this to the console, our apple count is 2, which is greater than 0. So I have apples is being output to the console. But let's say I had 0 apples. We can see that it's outputting I have no apples. We can of course flip this to say greater than or equal to 0. But in this case, we want at least 1 apple to say that I have apples. And in any other case, we will say I have no apples. So because apple count is greater than or equal to 1, we'll say I have apples. In any other case, we'll say I have no apples. So let's see what happens in this case here. Apple count is 0, so we should see I have no apples in our console. And we can see that that's happening here. And then as soon as we have at least 1, we're going to output I have apples. So let's bring this into a little bit more practical example. So let's say, for example, I am attacking some mushrooms and I want to do a check of if this is a valid target or not. Because in my world, I can only attack mushrooms and any other type of monster is invincible. I can't attack them. So what we can do in our validation check to see if our monster name equals the mushroom type, we will say target mushroom name, and we'll use a double equal sign here as a comparison operator as opposed to the assignment operator here where we assign target monster name to mushroom. And instead we are using the comparison operator to check if the monster that we are currently attacking is mushroom or not. So if it is mushroom, we'll say valid target. And otherwise, we'll say invalid target. So because target monster name equals mushroom, we should see, and we'll log out our target monster name here. And since our target monster name is a mushroom, we'll say that I have a valid target. But let's say that I am attacking a pig, for example, and I'm not able to attack a pig yet. It should now log invalid target. So since our monster type is a pig, we are seeing invalid target. So we can flip this to the opposite, where instead of equals, we can say not equals. And to signify that, we use the squiggly key. And now this is not equals mushroom. So if our target monster is not a mushroom, then we will say invalid target. And in any other case, will say I have a valid target. So let's try saying mushroom. And because our target monster equals mushroom, our else condition should execute here to say I have a valid target. If it was not a mushroom, then we would say invalid target. Here, because our monster name is mushroom, we're saying I have a valid target. But if it was anything else, like a pig, now we are saying that this is an invalid target because we cannot attack a pig yet. So later down the road, our character levels up, and now we are allowing you to attack both mushrooms and pigs. So let's, for the sake of simplicity, flip this back into the other format, because I find this a little bit easier to read than the previous version. And we also want to now start attacking pigs. And we can utilize the OR keyword to say if target monster name equals mushroom, or if target monster name equals pig. So even if our target monster's name is pig or mushroom, it will say I have a valid target. If it's anything else, it will say invalid target. So let's try pressing play. Our current target is a pig, so it's saying that we have a valid target. And if we change this to mushroom, and we press play, it still says I have a valid target. Now let me introduce a new type of monster, slime. And now if I press play, because our target is a slime and it doesn't equal mushroom or a pig, we are outputting the else condition, invalid target. So let's add just a little bit more complexity into this here. Let's say that we only want to be able to attack monsters that have greater than 0 health. So they have to have at least 1 health so that we can deal damage to it. Otherwise, we can consider that monster already defeated and we can no longer attack that monster anymore. So let's give our monster a health of 5. So for the sake of simplicity, let's get rid of our second conditional here. And now we have to say that if our target monster health is equal to 5 and the target monster name equals mushroom, then we have a valid target. So let's use target monster health equals 5 and target monster name equals mushroom. So both of these have to be true in order for us to resolve the if condition. In our other example, where we use the OR keyword, one of those had to be true in order to activate our if condition. But in this case, because we use the AND keyword, both of those have to be true. Otherwise, if even one of these is false, we will execute the invalid target, our else condition. So here, I incorrectly said equals to 5. We have to say if it's greater than 0. So if our monster health is at least 1 or more, then we will have a valid target. So now let's press play, and let's also log out our target monster health here. And we're seeing invalid target because our target monster name was a slime. So even though our target monster health was greater than 0, because our target monster name did not match one of the conditions, it's also resolving false and executing our else condition. So let's change this to mushroom. And now both of these conditions are true. Target monster name is mushroom and target monster health is greater than 0. So let's press play. So we have our target monster, which is mushroom, and our health is greater than 0, so we now have a valid target. And then now let's take it one step further in complexity and add back in our OR condition. So we can group certain conditionals together so that anything within these parentheses, if the final result equals true, then we group that together as a single value. So let's say that now we also want to check if our target is either a mushroom or a pig, so just one of these has to be true. And if this is true, then we will execute our lines of code here. So our target monster name is a mushroom, and our health is 5. So this time let's try changing it to pig. And now press play. We are saying that we have a valid target because our target monster name is either a pig or a mushroom, and the target monster health is greater than 0. This will also work when we have a mushroom. So when our target monster name is mushroom, or it's a pig, and our target monster health is greater than 0, we are saying that we have a valid target here. So last episode, we learned about the concept of functions, and functions are a great way to reutilize and reuse scripts that we see being used often throughout our code. Let's say, for example, we need to duplicate this logic here, this if-else statement where we're checking for a valid target, and we have to use it again later down the line. It's a lot easier to call a function that pre-exists and then pass in our variable into this function, rather than have to copy and paste this logic in every single place that we need to use this logic. And this way, let's say later down the line, we want to change how our logic works and we want to add in maybe another target monster that's available, or we want to check if the monster health is greater than a certain amount instead of 0. It's a lot easier to just change the function itself rather than have to go and find every instance where we've used this logic and change that. So let's change this into a function by using the function keyword, and we will name this check valid target, and we will have input parameters of the target monster health, and we'll have the end keyword to mark the end of our function. Then we'll just copy and paste this logic into our function, and then let's bring this down below our function. So we have our function all the way at the top, and then we have our logic after that. We also need to give it the target monster's name, so we need the health as well as the name. So we are inputting our target monster health and the target monster name, and we are checking if the monster name matches mushroom or pig, and we're checking if the target monster health is also greater than 0. Then we will return a value of true or a value of false. Return true in the case that it is a valid target, and we will return false in the case that is not. So next we will have our target monster name. Let's say our target monster is a mushroom and our monster health is 5. We will first check for the condition. So we will do if check valid target, and we will pass in our target monster name, and we'll pass in our target monster health. Then we'll have a then keyword and an end keyword to mark the end of our if-else statement. So because we're calling check valid target and it's returning a value of either true or false, we know that the final value here is either true or false, which is again a Boolean value in between our if and then keywords. So if it's true, then we will resolve our if statement, otherwise it will not resolve. If we had an else statement, then we will resolve the else statement instead in the case that check valid target returns false. So in the if statement, what I want to do is I want to calculate maybe some sort of damage. So we first checked if our target is a valid target, then we want to deal some sort of damage to our target. So let's calculate our damage, and we'll create another function here for that. So we'll press enter twice, and we will have our damage function, and we will have our function keyword, and we'll name our function calculate damage, and we'll pass in two parameters, damage value and the defense value of our monster. So the damage value will be the damage that we will be dealing to the monster. The defense value will be the value of the defense of the monster that we are targeting. We'll also have the end keyword to make sure that our world knows where our function ends. Then we will have another variable, net damage, where we subtract the damage that we are dealing from the defense and see if that value is greater than 0. If our defense is higher than the damage that we were trying to deal, then we won't be able to deal any damage. So let's do another if-else statement. So we'll have the if keyword, and then we'll check if the net damage is greater than 0. Then we'll return our net damage. Else, we'll return 0. So we will have either the net damage, which is if it's greater, then defense will be the difference between damage and defense. However, if damage equals defense, or if defense is greater than damage, it will be either 0 or it'll be less than 0, meaning that we haven't done any damage, so the final damage value will be 0, or in other words, a miss. So in our check valid target, we've already checked if this is a valid target. So then in our if condition, we will try logging out our final damage. So we'll do log the final damage is Then we will concatenate that with our calculate damage. So let's give our monsters some defense values. So we'll have a local target monster defense. And let's say that our monster's defense is 5. And let's also log out the target monster's defense. Then let's give ourselves a power. So we will have a power value of, let's say, 6. So in this case, our target monster's defense is 5 and our power value is 6. So the difference of that is 1, so we will have a positive damage to deal to the monster. So we'll pass in our values. So the first value that we should expect to pass in to our calculate damage is the damage value. So we will pass in our power value because we'll deal damage equal to our power value. Then we'll also pass in our target monster's defense into our calculate damage. Then this calculate damage will return either a value of the net between the damage and the defense, or it will return 0. So let's see how much damage that we deal with a power value of 6 and a defense of 5. So we have an error message here, and this is because I have accidentally passed in the wrong values into check valid target. The first parameter is expecting a target monster health, but instead I've passed in the name. The second value that it's expecting is a monster name, but I've passed in the health. So let's switch these around. And now it should work. The reason we got this error was because we were comparing what was expected to be a health value, but instead we passed of a string type, and it was comparing against the number type, which is invalid. So let's try pressing play one more time, and then see what we get. So now we're properly getting our values here. So first we have a target monster name, which is Mushroom. We have a target monster health of 5. We have defense of 5, and we have a power value of 6. Because our monster name was Mushroom and our target monster health was 5, we've got a valid target. So this is being resolved, and the value true is being returned to this if function, to this if conditional statement. So if condition is being resolved. And then we are calling calculate damage, and we are passing in our power value of 6 and a defense of 5. So it's returning the value 1, which is the difference between damage and defense. And we finally got the final damage output here. In our else statement here of check valid target, we will say log unable to deal damage to this monster. So let's say, for example, our target monster name was a slime here. Then here it says invalid target, which is being returned from our else condition. Then in our else condition of our if-else statement here, we are returning unable to deal damage to this monster because check valid target returned false. So let's change this back to a valid target one more time. And then let's try increasing our monster's defense up to something like 10. So our target monster's defense is now 10 and our power value is 6, which means that the monster's defense is a lot higher than our power value. So it would result in a negative number. But because we said if net damage is greater than 0, if it's 0 or less, it will return 0, regardless of if it's a negative number or not. So the final damage should be 0. So it's not really as fun when our power value is a fixed number like this. So let's return our monster's health to 5. And instead of dealing a fixed value of 6, let's utilize a built-in library of MapleStory Worlds. And within our API logic, we will search the keyword random. And in our API reference, we can see util logic. And inside of the util logic, we can see that there is a return random integer range function where we can pass in a minimum and a maximum value, and it will return a random integer within the range of min and max. So this would be useful to randomize our power value between a certain range and add a little suspense of whether we're going to hit a monster or not. So let's use this function here. From the util logic script, we are calling the random integer range method and passing in a range of, let's say, between 2 and maybe 8. Let's log out what our power value is. Power value. Then pressing play. We can see that this time we have a random value of 2, which is less than 5. So we got final damage is 0. If you try pressing again, this time we have 3, which is still 0. Let's see if we can deal some damage here. So finally, we got a random value of 6, so our defense was 5, and the final damage was 1. So let's take a second look at our check valid target function here. So we are passing in the target monster's name, and we're checking if that name is either a mushroom or if it is a pig. Now, imagine that we are adding another monster, and another monster, and another monster, and suddenly we are checking for hundreds and hundreds and hundreds of monsters that we are able to target. This would of course result in hundreds of lines of code where we are utilizing the OR keyword over and over and over again, and it would be so unreadable. So instead, what we can do is we can utilize a table format. So remember from the last episode, we learned about tables and that they can hold a list of data. So we can declare a local targets table, and we'll assign some values to this. We'll say mushroom, and we'll add pig to this list as well. But how do we actually loop through this targets table and go element by element, checking if our monster name matches the elements within this list? Well, let's put this code aside for a moment, and let's focus just on loops and how they work. So the first type of loop, and there are several types of loop to go over, but the first type of loop that I'd like to discuss is the for type loop. So the for type loop loops between a range of numbers, starting with our variable I, and this could be named any variable that we'd like, but this is just a variable that I've declared for this for loop. And this variable will exist only within the lifetime of this for loop, and then will be destroyed as soon as it exits and completes the for loop. So our temporary variable of I is being assigned to the value of 1, and it is looping over and over and over again until it reaches the value of 10. So every time it reaches the end of our for loop, it increments our value of I by 1 and then goes again until our value reaches 10. So let's log out the value of I, our temporary variable, and see what happens in this loop. So our initial value is 1, and it's being output here. Then I, after it reaches the end of our for loop, it's being incremented by 1 and going again until it reaches a value of 10 and then stops looping. We've got another type of loop, the while loop, and we have the keyword while, and then as we've done before, we have the keyword do, and then it completes with the keyword end. So while countdown is greater than 0, we will execute whatever's inside of this loop here. So this works similar to an if statement. As long as the condition that we input here is true, then we will keep looping over and over and over again through this loop until it reaches a state where the conditional would be resolved as false. So in this case, we are manually assigning a variable countdown to a value of 10, and we're saying as long as countdown is greater than 0, we will keep looping. And then each iteration of our loop, we are subtracting our countdown value by 1. So it would start at 10, and then it would be decreased 1 by 1 by 1 until it reaches a value of 0. So let's see what happens here. We're getting a value of 1. So let's get rid of our for loop for now, so we're not distracted by that. And let's try pressing play one more time. And we can see that we have our value 10. And at each iteration of our loop, it's decreasing 1 by 1 until it reaches a value of 1 and then breaking out of our loop. We also have something similar where instead of a while loop, we have the until loop. So what the until loop will be able to do is it will first execute the code inside of our function. So we have a repeat and until loop starting with the keyword repeat and ending with the keyword util, and then a conditional being passed into this keyword. So the way that the repeat until loop differs from the while loop is that it'll first execute the code before it checks the conditional. So regardless of whether or not our condition is true or false, it will initially execute our code before checking our conditional. Otherwise, in every other way, it's exactly the same. So let's press play. And we can see it does the exact same thing. We have an initial value of 10, and every iteration of our loop, we are counting down, and we are subtracting our value by 1 until it reaches 1, and it breaks out of our loop. So the difference here is that let's say that we have a value that wouldn't work for our loop. So for example, -1 is less than or equal to 0. So it does not match this conditional, but regardless, it will run at least one time first before it checks our countdown. So the value that's outputted should be -1. So here we can see that it's outputting our value first before it checks the loop and breaks out of it. Let's bring our countdown value back to 10, and let's bring our while loop back, because I find this a little bit easier to look at. And in here we have what's called a wait. So our current version of countdown is a little bit boring in that it does not actually work like a countdown timer. It just goes from 10 all the way to 0 in a single moment. So what we can use is the wait keyword, which will stop execution of our code completely for the duration of time that we specify. So this is a keyword native to Lua, but we can utilize our wait keyword to wait 1 second at each iteration of our loop. So if we press play now, our initial value is 10, and we can see every second it's outputting a new value to the console instead of outputting immediately all at once. So it reached 0, and now it's no longer outputting to our console. The drawback of utilizing our wait keyword is that it will halt the execution of our code completely. So in the case that we wanted other code to execute while this countdown timer is running, it would not make it possible because our wait keyword is pausing execution of all code. What we can do instead is we can utilize our timer service. So let's hop back into our API service and let's search for the keyword timer. And we have a guide here where it shows how to create a timer. But let's go into our timer service logic here. So inside of timer service, we have a set timer function that will allow us to pass in a function that we will keep repeating over a certain interval until we utilize the clear timer to stop our timer. So let's return to our code here, and instead of wait, let's define our timer. So let's declare a local variable named timer, and for now let's assign it to a value of 0. Then we'll define another variable named callback, and we will assign this to a function. So this is an unnamed function that we are assigning as a value to this callback variable, and the contents of this function will simply be our timer. Now that we have the function that we want to pass into our timer, we will now set our timer to be utilizing our set timer, and we'll pass in a variable named as self, and we'll learn about the self in a future video. This is specific to MapleStory Worlds, but for now, we will just say self. Then we'll pass in our callback function that we have assigned as a variable here. Then we will give it an interval of 1, and we will say that yes, we are looping through this. So just to reiterate, we've passed in our callback, we've given it the interval of how often it will repeat, and then we've said that it does repeat. So now that we've started the timer, we have to clear the timer after a certain condition. So what we will do is we'll say, if the countdown equals 0, then we will clear our timer. So we're looping through over and over and over again, and we're counting down from 10 all the way to 0. As soon as it hits 0, then we're going to clear our timer. And we've passed in our timer value, because when we set our timer, it returns an index or an ID for our timer, and we can simply use that again to clear that specific timer. So this will run exactly the same way as our wait statement did, and it's a little bit more complex, but this will now allow us to execute code while our timer is running. So one mistake that I've made is that because we are calling our set timer over and over and over again over a certain interval, and in this case our interval is 1, we no longer need to utilize our countdown value, and we can simply execute the function inside of our callback here. And this will be called over and over again over the interval that we've set. So this will run exactly the same way as it did in our while loop. So we start at 10, and then every second it is updating a new log to our console until it finally reaches a value of 0 and breaks out of our loop. So let's return to our initial example here, where we have a check valid targets array, and we have a targets table that contains all of the monsters that we want to check against. We're passing in the target monster name to this function, so we want to check if the target monster name matches any of the elements within this table. This is a much better alternative to utilizing the OR keyword and checking against every single monster. So we have to loop through this array, so we'll get rid of all of the code that we had initially, and instead of using the if-then statement, we will utilize our for loop. So we'll do our for keyword, and we'll assign it to the initial value of 1, which will become the index of the first element of our targets table. And we have to give it the maximum loop value of how long it's going to loop until. And that should be the length of our targets array. So to get the length of our targets array, we simply utilize the pound symbol and pass in our targets table. And we'll use do keyword and the end keyword to mark the end of our for loop. Then we will do if targets I, which is the index that we are accessing at each step of this for loop, equals target monster name. Then we want to say that we have a valid target. So let's give this function a Boolean value. So we'll say local valid target equals false. And then let's return at the end of the function, return valid target. So at the start of our function, we are assigning our valid target to false, and as long as it finds something within our targets table, we'll say that it will say valid target equals true. So if it finds anything within this targets table, then we'll assign our valid target to a value of true to return at the end of our function. However, let's say that our target was a mushroom and we found the mushroom in our table, but because we're still looping through this array, it will then again check for pig and then say it's false. So we have to stop the loop as soon as it finds the proper element and then break out of the array. Otherwise, it should keep looping through, and then if it doesn't find anything, it will remain false. So here, we will utilize the break keyword that we learned about. And as soon as it finds a valid target, then it will assign valid targets to true and break out of the function so that when we return the value, it will be a true value. Then as a final check, we will say valid target equals valid target and target monster health is greater than 0. So here we're saying that if valid target is true and if target monster health is greater than 0. So we've checked for if our target monster exists within this table and if the target monster's health is greater than 0. And we're returning the final value for valid target. So let's see if this does the same thing as it did before. And it sure does. We have a value of mushroom, and the target monster's health is 5, which is greater than 0. And we have a target monster defense of 5, and we have a randomized power value, and this time it was assigned to 6, so the calculated damage is 1. Let's try setting one of these conditions to false. For example, let's say the target monster health was 0. This should return false. So because our monster's health was 0, it's saying unable to deal damage to this monster. Let's bring the health back up to, let's say 10. And press play one more time. And we can see that our damage calculation is still working. That's everything that I have for you today. Thank you so much for joining me in today's video. Today, we've taken a deeper dive into some programming concepts by learning about various conditionals that allow us to build our own logic and put our various data types that we learned into conditional statements, comparison statements, using timers to schedule execution of our code, and many other types of logic. And now that we've got a baseline understanding of general programming concepts that might apply to any language, next time, let's finally learn about what makes programming in MapleStory Worlds unique.